Hello, everyone. I just wanted to do a little calculation thing that might be helpful. So I'm going to do on my first process. It says a pediatric patient weighs 96.8 pounds. The prescribed medication dosage is 15 milligrams per kilogram per day to be given 3 times a day by mouth as needed. What is the amount of medication in milligrams that should be given per dose? Okay, so always read what the question is actually asking you, because it will help you determine like what's fluff or not, which is like half the battle, honestly. So we're gonna do what we have, which is what the patient actually weighs, and then we're gonna do the medication dosage. This is kind of like the rules that they have for that, and then we have the actual question, which is per dose. They're asking us what is it per dose. And then we are going to have the frequency, which is very important, which is 3 times a day. So, first things first, we're going to have to write down what we have. 96.8 pounds. But we're like, okay, but how are we going to get the dose in milligrams if it's 15 mg per kg in a day? That's where our conversion factors come in. 1 kilogram equals 2.2 pounds. So, okay, now we have the weight of the pediatric patient and we have the conversion factor. How are we going to bring this all together so that we can get what we want, which is the mg? They're asking us about mg, the question. So we're going to do 1 kilogram over 2.2 pounds because they equal each other. 1 kilogram is the same thing as 2.2 pounds. They represent one another. So then we're going to do, okay, at the denominator, it's always going to be the same. When you do the equal, remember the equal, the denominator is always the same, which is different from dimensional analysis, which is multiplication. So I'm going to show you both ways so you can see how they're different. So because they're like that, pounds is going to be at the bottom. Instantly, we just know that pounds is going to be at the bottom on the other side as well. Okay, so now on the top, which is the numerator, is kilograms. So what's going to be on the other side? It's also going to be kilograms in the numerator because we know kilograms on the other side is like that. So what are the numbers? Okay, we don't know the kilograms yet, but we do know that our patient is 96.8 pounds. So that's what we're going to write, 96.8 pounds. But we don't know the kilograms yet. But that's what we're going to get to because we already have 3 numbers. We have 1 kilogram per 2.2 pounds. And then we also have the weight of our patient, which is 96.8 pounds. So how do we actually calculate this? Well, there's a trick to it. And it's like a butterfly thing. You go across of all the knowns. So when you go across into a circle, it has to circle up to 2 numbers across. And then you have to multiply that. You always multiply the 2 numbers that are circled. And then for me, I like to square off the bottom. And then you always divide this one. So, what do you mean by multiply and divide? Let me go color code this a bit. So, we're going to do this, and this. So 96.8 pounds times 1 kilogram is divided by 2.2 pounds. Which equals, okay, so this is going to equal, oh, this app is called Cola Note, by the way. Cola Note. note. Anyways, this is going to equal 44 kilograms because pounds cancel out with pounds and we're left with kilograms. So we have 44 kilograms, and 44 kilograms is the same thing as 96.8 pounds. Both of them are the same thing. It's just we're changing the unit. So when you change the unit, the number changes. So it's just another way of representing the same thing in the world. So now we have our patient in kilograms. So now we're going to have to figure out how much is it per dose based on that kilogram. But we can't just jump there. We have to first use a very important thing, which is kind of similar to the conversion factor. We have to use the medication dosage, and it's here. So we're going to just do what's important for us. Milligrams is important and kilograms is important. So we're going to use those things. So we do know that this whole thing is for a whole day. But is a dose for a whole day? When they say per dose, think, is it for a whole day? No, because you're giving a dose 3 times in a single day. So because TID means 3 times, that means that per dose is not going to be per day. It should be something less than that. So let's first figure out how much it is. Milligrams. Or you know what? Grams per kilogram. And this whole thing is for a whole day. So I would just say this is like 1 whole day. This thing represents a whole day. Because you can't see the white there. And then this equals... Okay, so what is going to be at the bottom? Again, remember, the bottom always is going to match. So it's going to be kilograms at the bottom. The numerator, which is at the top, is going to be milligrams. This is going to be 15 milligrams. No, that's not going to be 15 milligrams, sorry. Whoops. So we have kilograms, which is 44 kilograms. And we don't know how much milligrams it is yet. So that's X. So we're going to do the same thing that we did last time. We are going to, let's use this color. We're going to go across this square. So 15 milligrams times 44 kilograms divided by 1 kilogram equals 66. So 66 milligrams. So that's 660 milligrams. And this is for a whole day. This is 1 day. So that means that this is also 1 day. So 660 milligrams is going to be literally into somebody's body, inside of them, if they're feeling pain as needed. And that's going to be for the whole day. But they're asking per dose. They're not asking for the whole day. And per dose is tied to this. So we're going to have to move our number down here. We have 660 milligrams. Which is, so 660 milligrams is 1 day which equals TID. So that's like 3 times in a day dose. That's the milligrams 3 times in a day. So you could just say 660 milligrams is for 3 times, or you could just say for 1 whole day. And then we have to equal that to, so if 1 day consists of an amount of milligrams 3 times a day, doesn't that mean that what we want is going to be 1/3 of like the amount in the day? Like theoretically, it should be 1/3 of that. So what I would do is I would do 1/3 a day, and then that equals X mg. Or if you just want to just skip over all that stuff, you could just like see it's 3 times a day, and you know the total amount, which is 660 milligrams. So you could just do 660 milligrams divided by 3, and they'll both give you the same number. So let's see, 660 divided by 3, which is 220 milligrams. And for this, remember, a fraction divided by a fraction is the same thing as multiplying it by its reciprocal. You do 220 milligrams, and it's the same, basically. So you go to the same answer in the end. So depending on what you want, you do that, but TID led us to 3. Another way to look at it is TID means 3 times per day, and we already know that it's 660 milligrams per day, and they're asking us per dose, which equals 1. Not 3. So what you can do is you can just look, okay, it's 3 times a day, and this is 660 milligrams total. So you could just go from there and do 3 times equals 6 mg, because they both is like a day, they're both per day. So like they both represent 1 day. It could be like this, 1 day, and this both represents 1 day. When 2 things represent the same thing, you don't really need them there because they represent the same thing. So then you could just do divide by 3 equals X, which is 20 milligrams. That's another way you could look at it. But yeah.